continuing with the next type of inheritance. We have covered in the last session, we have covered single level inheritance, multi-level inheritance examples. We have already covered this part. Okay. So today we are going to start with the next part, that is, as well as we have seen this static and dynamic binding concepts also, right? And today we are going to see hierarchical inheritance. This is the next type of inheritance where we are going to, this is nothing but one type of inheritance in Java, that is hierarchical inheritance, which occurs when one base class, and that is a superclass, is inherited by multiple subclasses. Okay, so multiple subclasses of a single class. In this type of inheritance, all the features that are common in child classes are included in the base class. Okay, so for all the features are included in the base class, you can include everything into the base class, or you can say that that is a parent class. This way the code becomes more manageable and reusable. This is an example where the class A is a parent for class B, class C, class D. Okay, so we will see this through one example here. Class B and C and D inherits the same class A. Class A is a parent class, and all these three are its child classes. So whatever the three classes have a common code, that you can write everything into this one class, that is into the parent class, and you can write the different parts or different codes, which is only that available for these classes. You can write those. Okay. So we will see one example. This, to create one class here inside the module 10, new class. Name of the class we are going to mention, that is hierarchical inheritance. This is, I will include the main method as well. So in this example, we are going to create class fruit. So all the fruit related properties you can write here into this class. For example, string color, right? All fruits have colors, right? So the common properties we can add here, that is string color. Then you can add any other, that is name of the fruits, right? So all fruits have name. So we can write string name as a property of the fruit. So these are common properties for all the fruits that I am adding or writing inside the parent class fruit. Okay. We will generate toString method as well. Okay. And we will generate the constructor source constructor from superclass, that is nothing but default, and parameterized constructor as well. Constructor using fields. Okay. Both constructors I have written here, and I have included toString method as well, right? Now we will create, if that is not required, you can skip these parts also, okay? Because you know that the default constructor is automatically created by the JVM if you are not defining any constructor. So we will add, or we will inherit it fruit class into two different classes. This class, suppose the class name is apple, which extends fruit. So by default, this child class will have these name and color properties, right? So we can add only apple related properties here. Child class. Now I'm adding I'm not going to add any property here. I will directly add one method, that is benefit of apple. So we will create one method, void display benefit, apple benefit, I will write. Okay. And you can display anything you want here into this method. This is just for you to understand how the hierarchical inheritance works. Okay, nothing else. So this is, I will write one statement that is apple is good for health. Okay. Now we will create one more child class. That class is suppose guava, which extends again fruit class. So again for this guava also the name and color will be inherited directly because this is a child class, right? So here I will add one more same type of method. Basically, I will only change the name, display guava benefit. Okay. Okay. Now here we have created one fruit class with two properties or two members, that is color and name, included the constructors and one toString method here. We have inherited two classes from that. One is apple and second one is guava. Okay, these are two child classes, subclasses. Now we will execute this by creating different objects. So first object we are going to create is child classes apple. Okay, so first we will create the apple class object. Apple A is equals to new apple. So by default constructor I am calling. Okay, the default constructor gets called. Now you can directly call the method that is display apple benefit. If you want to set the values for the color and name, you can set it through this object because these are directly accessible to the apple class. A dot name I'm giving some name here. Okay. Now I'm calling the display apple benefit. If I want to see the data I have stored for this, you can directly use system.out.println and you can display this A object so that you will be able to see. It internally calls the toString method. And in toString method, if you are not writing any toString method for this apple class, then but we have written one method into the fruit class, so you will get the values. Okay, so this is fruit, color is red, we have said the names given, and this is the display method we have called for the apple. Okay, this is the apple object. This is a direct child class object. You can create the object of parent and we can save the child reference as well. So here I will add one statement, system.out.println. Parent object, store child reference, right? We have seen this part previously also. The same you can use here. Fruit, suppose I'm using fruit is the object name. And here we are initializing it to apple itself. Okay. Now, fruit object can access the properties like color, and you can set the name as well. Fruit dot name is equals to but you cannot access fruit dot display method. We are not able to access it because, as we have seen, child members we cannot access through the parent object. Okay, so this is not accessible. This example, we can only access all the members of fruit class, that is parent class. I'm executing this, you can see the output. So you can see this output, you will be able to, but you cannot do this statement because that method will not be able to called using the parent reference. Okay. So this is when you are creating a parent object and you are saving into the child reference, you are initializing it with child reference. You can access only parent of parent members. Okay. You cannot access this child members directly. Similarly, we can create the object of child guava class. I am creating the object of guava class. You can set the members guava.name is equals to giving some name and its color. You can access display method also, and you can access toString method also here. Okay, everything from parent and child you can access when you are creating the child class object. But here also, I will say you cannot access the another child classes method, that is this method using the object. Okay, not this one. We will see that in the next example. So this is a guava class we have initialized and everything set. You are calling a method, you are getting the whatever the output you have set. Okay. Similarly, like this, you can create the parent object, fruit 1 is equals to new guava. Now I am initializing it using guava. Okay. And here I am setting the values for color, and I'm setting some name to it. Similar to this example, you cannot access the child class member, that is display guava benefit. You cannot access using this fruit1 dot display guava benefit is not accessible. Similar to this, you cannot access fruit1 dot display apple benefits, that is another child class member. That also you cannot access, though you are creating the parent reference. You cannot access the another parent child class member and initialized child class member as well. Okay. So anything from this guava object also you cannot access the apple benefit method. So these are rules when you are creating any project. You should understand these things. You can access only parent members. System.println. Here I can write down fruit one. Yeah, we will execute this. So you can see the output is correct. Okay, so this is an example of hierarchical inheritance where one parent, all the common properties for child classes, you can write it here and create one parent class. You can inherit it into multiple child classes. That is known as hierarchical inheritance. Any doubt, anyone? Clear with this example? Shall we go ahead? Next example is multiple inheritance. Multiple inheritance refers to a feature in object-oriented programming where a class can inherit properties and methods from more than one class. For example, here I am creating one class in the same package. I'm creating a class multiple inheritance example, including a main method. Okay. Now here, suppose there is a class A and there is a class B. Okay. This class A has method. Suppose the method name is display. Something is there in that class. Void display. Same method is here into this class B. The members of this class A are also suppose same. It has one member that is name, and class B also has one member that is name. Okay. Now, this is the basic classes, two different classes. In a multiple inheritance, what happens? We can inherit from multiple classes in a single class. Okay. That means multiple parent classes, one child class. So this concept allows a subclass to inherit behaviors and attributes from multiple base classes, that is superclasses, parent classes, creating a rich multi-phased hierarchy. So these are two different classes and we are inheriting into one child class. But in this example, class C is a child class. It inherits class A and class B, all the properties of class A and class B. But in Java, it is not supported through classes. Okay? Multiple inheritance is not supported in Java through classes because there is a complexity and potential for ambiguity it introduces. That is known as diamond access problem or ambiguity problem. So what is mean by that? So as I explained, there are two classes. It has two members. First is the name property and display method. Same members we are writing for the class B also. And I'm inheriting one class C, which extends A. When we use a multiple inheritance, we basically use multiple parent classes. We can separate it using comma. Okay. So this is the syntax for creating the multiple inheritance. But as you can see here, this is a syntax error. You can see it is not supported in Java through classes because there is an ambiguity problem. Why the ambiguity is? There are two members, okay, with the same name. Display method is there in the class B and class A also. If we try to create the object here, suppose class name is C. I'm creating the object of C. And I'm trying to call display method. Okay. Then when you're calling the member, if that display method is not a part of this class C, and you're calling that member, that is any method, the compiler will get confused. Why it will get confused? Because there are two parent classes, A and B, and both have the same name for the methods, like display method. So it will get confused whose display method to call, whose parent's display method to call. Whether it is of class A, we should call, or we should call from the class B. That is why the compiler gets confused. And this is known as ambiguity problem, diamond access problem. Okay, this confusion is there, and that confusion leads to basically not supporting this multiple inheritance. Okay, so that is why multiple inheritance is not supported in classes. Okay, we can achieve the multiple inheritance through interfaces. Clear? Understood? Any doubt? Instead of multiple inheritance for classes, Java provides a mechanism to achieve the polymorphism and code reuse through interfaces. So we can achieve all inheritance types through interfaces, including multiple inheritance. But in classes, we cannot use this multiple inheritance, or it is not supported in classes. Clear with the two types? Multiple inheritance and hierarchical inheritance. Any doubt? Understood this problem? Ambiguity problem, diamond access problem, why the multiple inheritance is not supported. Everything is clear, everyone, right? Shall we go ahead? Okay. So I think everyone understood. So we will go ahead with the next type, that is a hybrid inheritance. Hybrid inheritance is a combination of two or more types of inheritance, such as hierarchical, multiple, multi-level, or single inheritance. Okay, so basically it is combination of all the inheritances. It integrates various inheritance mechanisms to achieve specific design or functionality. However, it is important to note that it is due to Java's restriction to extending multiple classes directly to avoid complexity and ambiguity problem. As I said, diamond access problem, diamond problem. Hybrid inheritance is also not supported in classes. Okay, we can, or that is using inheritance, but we can achieve it through implements keyword, that is nothing but interface implementation. Okay, that means it is also achieved through interface, but we cannot achieve it through inheritance, that is classes. Okay. In Java, hybrid inheritance can involve single and multi-level inheritance through classes. One superclass, then another class inherits from the subclass, forming a linear inheritance chain that is known as, we have already seen this, multi-level, single, multi-level inheritances. Then the hierarchical inheritance to classes, which we have already seen that multiple classes inherit from a single parent class. Okay? This is also one example of hybrid inheritance, because single level inheritances are there and it is hierarchical one. Okay, this is the syntax for basically combination of everything. Class A, class B, class C, class D, they are inheriting each other. So this is multiple inheritance through interfaces we can achieve, and combining class inheritance and interface implementation together, we can achieve the hybrid inheritances. Okay, so they are inheriting each other basically, and we can achieve the hybrid inheritance through this. Okay, so this is basically this one parent class, two child classes, means this is hierarchical inheritance. Then again one child class derived from the two parent classes. This is a multiple inheritance example, but that is not supported in Java. That is why this hybrid inheritance is not supported. Okay. We are not going to see any example for this because this is nothing but a combination of everything. We have already seen the combination of this single multi-level inheritances. Now the next concepts are polymorphism. We have already seen what is polymorphism. That is nothing but it is a Java concept by which we can perform similar type of action by different ways. And the polymorphism means many forms. There are two types of polymorphism, compile time polymorphism and runtime polymorphism. We have already seen the compile time polymorphism, that is achieved using method overloading in Java, right? We have seen the method overloading concepts. Now in this inheritances, we are going to see the polymorphism concept, that is a runtime polymorphism method overriding. We can achieve the runtime polymorphism through method overriding. So what is method overriding? If a subclass contains same method name and type signature as a superclass, then by default the subclass method overrides superclass same method. Okay, that means superclass method gets overridden. Okay, it is always comes under the inheritance. We cannot achieve it in a single class. It is always comes under the inheritance because the classes should have inheritance concept. That means subclass and superclass should be there. So we will see one example of this. Before going forward, we will see some rules for method overriding. When you are overriding a method, it is basically access modifier and scope should be same. Subclass cannot reduce the visibility of overridden method of superclass. That means we can extend it. We can change the visibility. Visibility is nothing but you can give the access specifiers, private, protected, public, default, right? So you cannot reduce it. Okay, we will see that through example directly. So here I am creating one class. The name of the class I am giving as method overriding. Including a main method. In this example, we will create one class bank. This class bank will have some members like the member I will say that rate of interest. We can add double rate of interest. Then, okay, I am keeping only one member here. Okay, so we will create constructor, default constructor, and I am setting some value to this. This dot rate of interest is equals to, suppose current rate of interest is 8.2. I am going to add one method. That is a getter method. I want only getter method. Okay, getter and setter methods are there. Okay, but I just want rate of interest getter method. I don't want setter method, so I will only select the getter. Generate. Okay, so only getter method is generated, which is returning current rate of interest. This constructor is with public accessibility, and I am generating toString method. Okay, it is returning bank's rate of interest part. I am modifying this statement. Rate of interest in bank class is equals to this rate of interest value I don't want anything else. Okay, you can modify if you want anything or whatever the output statement should be, you can change it here. This will be updated when you use the string representation of any object. Okay. Okay, bank class is already defined in I'm changing it to bank. Okay, I will change it to bank 1. Now I am inheriting one class from this class. Suppose the name of the class is SBI, which is extends this bank 1 class. Now this rate of interest will be by default available for this bank SBI class, right? So in this SBI, I am overriding this method, get rate of interest method. directly without defining this member. Okay, so how to do that? You just have to use this get rate of interest, same method. The signature should match with the parent class. It is exact same method. You can change only the statements under that, or you can say that definition of that method. You can change it, but you are not going to change anything as a signature. That means number of parameters, the name of the method, return type of the method, and access specifier. So what could you can change that we are going to see through the rules. Okay. So here, this get rate of interest method is going to return the rate of interest. I will define one rate of interest member here also. Double same member I am defining rate of interest. And we are defining one constructor to set the value for this rate of interest. Equals to, suppose here I am setting the value 10.2. Now in this get rate of interest, I am returning at return statement. I want this member's value should be returned. Now this member is of SBI class itself. Okay, this is a member. We are using this for inside the SBI class itself. So the value of it we have assigned to 10.2. So this same value is going to return here. Now you can see there is a annotation. This is annotation at the rate override annotation is added because we are overriding this method from our parent class. Exact same method, only we are changing the statements or the definition of that method. The method signature should same as the parent class. This is nothing but the example of method overriding. This is overridden method, and you can add a notation override, or it will get automatically added in Eclipse. Okay, like here also, the toString method is defined in the object class. You are overriding that method here to change its implementation. So that is why the override annotation is added, and this toString method is again overridden method from our object class. So why we override methods? What is the need of overriding a method? If you don't want to give the same implementation in a child class, if you want to change the implementation of parent classes method, then you can override the method into the child class and change the implementation if you want. Okay. So here I am adding, suppose, two more methods, that is double calculate home loan. This is a member of child itself. Okay. So here I am displaying rate, current rate. Okay. So this dot rate of interest we will display. And after that, we will calculate. Suppose I'm considering that 20 years current rate of interest, this dot rate of interest, and suppose the principal is 1 lakh. You can change anything. This is just for your information. Okay, so I have created this is instance method. It is member of SBI class. And this is overridden method, which is we are overriding from parent bank 1 class, and we are changing its implementation. I have not changed here, but you can change it. It is doing the same operation. Okay. Now we can include toString method as well. Now I want inherited methods also. that is a toString from parent class and toString from child class, both. Okay. So I'm changing the statement here. Rate of interest in SBI class is equals to this rate of interest, and I don't want this statement. We can directly call that method using super.toString that you know. One second. I'm appending at the start super.toString and then the rate of interest in SBI class. Okay. Now we will execute this using by creating objects. First, we will create the object of bank. B is equals to new, initializing it through child class. Okay. So SBI child class. Now, the name of the class is bank one. Here, we will first display all the details like system.out.println B object I am displaying. So the toString method of the bank one gets called or SBI gets called, that we will see through the output. Okay. Then I will create object of this SBI class directly. And we will display system.out.println S. Here we will call the method calculate home loan as well. Dot calculate home loan. Okay. Rate of interest we are already defining here. If you want to see the separate rate of interest method gets called or not, that we will see. Okay, first we will see the output of this, then we will see calling of the method. Okay, now you can see for the first bank B1 object from the SBI we have initialized, we are getting the output of toString from the SBI class itself. For the second SBI direct object, that is child class initialization, we are getting the same output. Okay, for home loan you are defining the rate and then the home loan calculated. Okay, so this is the representation of double value. So basically here, whenever you are calling the toString method, you have initialized it through child class. So it is automatically calling the child classes toString method. You are getting the output of child classes toString method by appending the parent toString values and then the child classes toString methods value, right? So it is basically calling the child classes toString method dynamically. This method call is known as dynamic method dispatch. Okay, you can call, suppose I am calling p dot rate of interest method also. System.out.println statement. Here, suppose you are calling this using bank object, that is a parent object. You are getting 8.2 value. 8.2 we have defined in the bank class itself, rate of interest. Okay, and if I am calling the same, sorry, not rate of interest, I want to get rate of interest method I want to call, sorry. 8.2 we have defined into parent 1 and 10.2 we have defined into child 1. What we are getting, that is the child value. So get rate of interest method of the child, that is SCI class, gets called because we have overriding this method. This gets called dynamically, and that is why it is known as dynamic method dispatch. It is known as dynamic method dispatch. Okay, so at the execution time, that is at the run time, the compiler decides whose method to call according to the initialized object, whose object you have declared, whose object you have initialized through, according to everything, if you are overriding this method or not. If you have overridden this method, then you will get the child methods implementation. Like here, if we are getting this and the toString methods implementation. So dynamically, it is deciding which method to call. That is why we achieve runtime polymorphism or dynamic polymorphism also, you can say, at the runtime polymorphism using this method overriding concept. Okay, so this is example of method overriding. Here we are overridden this get rate of interest method into this child class. You are able to getting this output of child class method implementation directly, though you are creating the parent reference. I already explained that part here. If you are creating the parent reference, you cannot access the child members directly, but the same method name is defined into the parent. Only implementation is different into the child. That is why you can call this get rate of interest here in overriding concept, and the compiler will decide at the runtime which method to call. That is why this is known as runtime polymorphism. Okay, any doubt? Now coming to this rules. First one is access modifier and scope. So first, that is what I am explaining. As we have declared this overridden method, get rate of interest method into the parent class with the public accessibility. So with the public accessibility, if you are defining, you cannot reduce the accessibility. That means you cannot make it private. No, that means you are reducing. By default, it is public. Public means accessible to any class, accessible from anywhere, right? So you are not, in the child class, when you are overriding method, you cannot reduce the visibility. Okay. So it private, if you are using, that means you are reducing the visibility to only class. If you are making it protected, then again you are changing its visibility from package label, and another package is child classes. It is also not, basically it is not, sorry, we cannot do this. We cannot basically change its visibility or reduce its visibility. Whatever the visibility you are defining in the parent class, you should keep it. You can increase it. Suppose in this bank one class, if you are making this method as default with the default accessibility, you can change it to public in overridden method. You can change its accessibility in overridden method by changing the access specifiers. Okay, but you cannot reduce the visibility. You can always enhance the visibility in overridden method. Okay, this is possible. Vice versa is not possible. This is the first rule, where subclass cannot reduce visibility of overridden method of superclass. Second one is return type. If the return type is primitive, should be same like original method. If it is non-primitive means, you know that what are the non-primitive data types, right? non-primitive data type, then covariants are allowed. So for in this example, we have used double as the return type for this, right? So if you are making it double, as you know that you can change, it is a primitive data type, you can change to class or not, it is not, right? You cannot change to wrapper classes, you cannot do that. In the overridden method, you cannot change it to wrapper class. But if you are defining that method with the wrapper class as the return type, that is object return type in the parent class itself, you cannot do this primitive change also, but you can covariant is allowed, means here the number is basically the parent one of the double class. This is also not possible. That is what we are explaining, that if you are keeping it as a primitive data type, you should keep it same in the overridden method. The first statement is that primitive should be same like original method. If the return type is primitive, it should be same like original method. If it is non-primitive, covariants are allowed. Covariants are allowed means you can suppose here in this method, in the parent class, this rate of interest method's return type is number. You can change that covariant, that is child classes, as a return type here. Like suppose here you can use interest, integer, double, anything. And now rate of interest is in double format. That's why it is showing you error. But the return type is allowed. Covariant is allowed. So we can keep the double wrapper class name also here. Okay. But if it has a parent reference as the return type, you can covariants are allowed. You can change it to child classes reference also. Okay. If it is a primitive data type, then you should use the same in an overridden method. This is the second rule. Now, next rule is method name should be same as overridden method. That is the main purpose. In the overloading method, we also keep the same name, but in a single classes. But here, same name, signature should be same. Everything should be same in the parent and child classes. Type signature, both the number of parameters and data type of parameters should be same as the original method. Exception handling in inheritances. So when you are overriding a method, there are few exception parts also. When we learn exception, you will understand that. But अभी के लिए सिर्फ ये rule याद रखो. If the superclass method does not declare any exception, if that method is not declaring any exception, then subclass overridden method cannot declare any exception, but it can declare unchecked exception. If the superclass method declares an exception, subclass overridden method can declare same subclass exception or no exception, but cannot declare parent exception. I will show you this through this example itself, but you will understand that when we learn the exception items. This is the parent method. I am not throwing any exception from this method. So in the overridden method also, you cannot throw any exception. This is the first rule. If the parent method is not throwing any exception, child also cannot throw, overridden method also cannot throw any exception. Then suppose this method is throwing exception. This method is throws, suppose, exception itself. Then same exception you can throw in the child class overridden method. If you don't want to throw any exception, that is also acceptable. If you want to throw subclasses exception, suppose that is, I am throwing arithmetic exception, that is also fine. That means exception is basically a base class, superclass. This is child class of it. So you can, in the overridden method, you can throw the child class exception. You can, if you don't want, you can skip that part, or you can keep the same exception throw part. Okay, but if the parent method is not throwing any exception, in the child overridden method, you cannot throw anything. Okay, this is the exception handling part in the rules of method overriding. I already explained this dynamic method dispatch. We will revise this part here. Here we use the one concept, superclass variable can refer subclass object. We can call the methods of superclass and subclass dynamically by changing the type of object which is referred by superclass reference variable. The call to the method is decided at runtime. This way is used when we want to achieve runtime polymorphism. Okay, this is way to achieve runtime polymorphism. We cannot change the implementation of subclass methods by adding the statement of super. Okay, so you can, this is everything is decided at the runtime. That is why this is known as the runtime polymorphism. And it is, which method should be called? It is dynamically decided. That is why this is known as the dynamic method dispatch. Okay. The difference between method overloading and method overriding is same name, different type signatures. Either the number of parameters or data type is different, but in the method overriding, everything should be same name, same type signature, both number of parameters, data type should be same. Subclass method overrides superclass method. Okay, that is important. It can be in the same class or inherited class. Method overriding is only possible in inheritance. Method overloading is a concept of compile time polymorphism, and method overriding is runtime polymorphism. Method overloading, access modifier and return type does not matter while overloading the method, as compiler only checks the parameter matching. But in the method overriding, access modifier, return type matters while overriding the method. There are certain rules regarding giving scope and return type in subclass that we have already covered. Okay. When we use the method overloading, it increases the readability of code, and in method overriding, it always increases the reusability of code. Instead of writing the new method in the child classes, you can use the same method name, same type signature, everything, only the implementation will be different in the method overriding concept. And why we use method overriding? Suppose child thought that some methods implementation should be changed according to their need, then you can achieve it through method overriding. So that is why we override methods, but only to change the implementation. Clear? Okay. So we will, whatever we have seen here, parent object with child initialization, this is known as upcasting concept. Okay. This is upcasting concept. And what is downcasting, and that part we will see in the next session. What is downcasting and how it is achieved, that we will see in the next session. Okay, so we will end our session for today here. We will continue with the next point in the next session. Thank you, everyone. We may leave the meeting.